Good day, grade 10 learners. Welcome to our mathematics lesson. I am Sikhulile Ncube. This lesson is probably brought to you by the Gauteng Department of Education. Right, what are we going to do today, grade 10s? We are going to look at the properties of quadrilaterals. Okay, we're going to look at the sides, angles, and diagonals. Okay, do you remember what a quadrilateral is? What is a quadrilateral? Is it a polygon? Yes, it is a polygon. Okay, with how many sides? With 4 sides. Quad means 4. Remember that. Okay, like tri means 3, quad means 4. So quadrilaterals have 4 sides. Can you name just a few quadrilaterals that we know? Let's try to name them. Okay, is a parallelogram a quadrilateral? What about a square? A rectangle? A kite? A rhombus? A trapezium? Do you remember all those quadrilaterals? Okay, right. We're going to learn about them today. We're going to learn about their sides. We're going to learn about their angles and also diagonals. Okay. You discover also that a square is a parallelogram. Do you believe me? A square is a rectangle. A rectangle is a parallelogram. Okay, right. Let's start our lesson. Let's be ready for the lesson. Right, your books in front of you. Okay, and your pen, your pencil, and your calculator. Let's start our lesson. Right, at the end of the lesson, you should be able to investigate and form conjectures about quadrilaterals. We're going to discuss these. We're not going to do proofs a lot, but we're going to just discuss and just finalize on the properties. Right, okay. Grade 8 and 9, we did geometry of lines. We're going to use that. Parallel lines, do you remember that? Corresponding angles, alternate angles, we're going to apply that today. And then co-interior angles, we're going to apply that today. Geometry of triangles, angles in a triangle, they add up to what? We're going to discuss that. And then congruency, and we're going to start by looking at congruency. Remember, in the previous lesson, we didn't finish our congruence thing. So I'm going to give you a baseline activity on congruence. Then we remind each other. Then we move on to the quadrilaterals. Okay? Right. Important terms. We've talked about this. Should I repeat? I said a quadrilateral is a closed four-sided shape whose interior angles add up to 360 degrees. I'm going to show you how we can get that 360 degrees. A conjecture. This is a mathematical statement that has not yet been proven, but once it is proved, it is called a theorem. Okay, theorem, it has been proved. Okay, right, now, I want us to do this activity, grade 10s. Can you try it? Okay, remember congruency? Do you remember the conditions for congruency? Side, 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 angle, side. Okay, angle, side, right angle, hypotenuse, side. Do you remember those ones? Okay, right. Can you try to prove that triangle BAD is congruent to triangle CDA? Remember, this symbol means congruency. Okay, do you remember that? Congruency. Let me write the congruency. See this E here? It's like that symbol there. Okay, remember that. Okay, the E there, those 3 lines there, they're like symbol for congruency. Then remember similarity, those 3 lines going down. Okay, let's try to do this. Let's try. I'm going to give you 4 minutes. Right, welcome back, grade 10s. Did you manage to prove that triangle BAD is congruent to triangle CTA? Congruence means exactly the same. Okay, is this triangle this one? Okay, you see this triangle? Is it exactly the same as this triangle? Can you say they're the same? Okay, right. What can we say there? Now, what are we given? We can say that angle B is equal to angle C. They are equal to 90 degrees. Why are we saying that? It's given. It's given that these two angles are equal. Right, we have AD, which is a common side for the two triangles. Do you see that? And then we have, and then that AD, if you check, is the hypotenuse for the two triangles. And then AB is equal to CD is given. Do you see that? Now, can we conclude and say these two triangles are congruent? Yes, we can. These conditions are enough for us to conclude and say these two triangles are congruent. Right. Why are they congruent? Because right angle, hypotenuse, side. Remember that, grade 10s. Okay? Right. That was what I wanted you to do. Now, we say that, grade 10s, we say that the angles in a quadrilateral, the interior angles of a quadrilateral, right, these angles here, A plus B plus B plus C plus D. If we add them, they give us 360 degrees. Is it true? Let's see. We want to see that. So now we're going to see that these angles add up to 360 degrees. What do we know, by the way? We know that angles in a triangle add up to 180 degrees. Do you know that? Okay, so let's see. Let's use that. Now we require to prove this RTP required to prove. We want to prove that if we're adding these four angles, we're going to get 360 degrees. Okay, try to listen now, and then I'll tell you when to write. Okay, especially when you go to the activities. Right, and then construct AC. You see, what have I done here? I've divided this quadrilateral into two triangles. I'm tempted to say these are two triangles, so 180 degrees plus 180 degrees gives us what? 360 degrees. Do you see that? Okay, but let's do it the other way. Okay, let me go back to a red pen. Right, construct AC. Now if you check, we have triangle ADC. This is a triangle. Okay, let me draw the triangle there. And then we have another triangle. I'm trying to pick another color. Right, we have another triangle, ACAB. Oh, CAB is the one which is red. Okay, this one is one which is red. This one is blue. Okay, right. I want us to move together. I'm trying to be slow so that we can move together. My colors are not coming out. So we have this triangle and this triangle there. Do you see the triangles? The triangle ADC and triangle ABC. Do you see the two triangles? We're going to be using these two triangles. So we're saying angle DAC. Do you see angle DAC? Okay, this one. Plus angle CAB. Follow the lines. CAB, which is this one. Right. Plus angle B. Let me use a dot there for angle B. Plus angle BCA. Do you see BCA? Start from B. BCA. It forms that corner there. BCA there, which is this one. Okay. Now, in angle ACD. Start from AACD. You see? Let me use maybe a star there. Okay. And then angle D. Let me use maybe two dots there. So if we add all these angles, we want to see if we're going to get what? 360 degrees, because these are all the angles. If I combine these two, that is one angle there. If I combine these two, that is one angle there. Okay, Right, let's see now. We're going to divide them into two triangles. Triangle ACD and triangle ABC. Okay? Right, let's look at triangle ADC. This is triangle ADC, this one. Okay? My work is becoming clumsy. I hope you will see. Where's my pen? Right, okay, it's not coming out. Right, and then triangle ABC, this side. This triangle, this side, ABC, which is red. Okay, this side. You see that if we add these two triangles, we must get what? We're getting all the angles. We're getting all these angles. There are all these angles in these two triangles. Okay? Right. Now, this triangle will give us how many degrees? This triangle will give us how many degrees? 180 degrees. This one will give us how many degrees? 180 degrees. Do you remember that? Okay. So we're saying this triangle, the blue one, will give us 180 degrees because angle is sum in a triangle. And then the other one, the red one, is going to give us 180 degrees angle sum in a triangle. Okay, so when you combine them, what do we get? We're getting 360 degrees. Do you see that? Very, very easy. I made it look complicated. We have divided this thing into two triangles. 180 plus 180, 360 degrees. Do you see that? Okay, so this is the most complicated thing for this lesson. Otherwise, from here, we're going to be enjoying the lesson. We're going to be enjoying the lesson. Okay, let's start to talk about quadrilaterals. Right, parallelogram. What can you say about a parallelogram? Two pairs of opposite sides are parallel. Okay, two pairs of opposite sides parallel. Two pairs. There's a pair, this side and this side, and another pair, this side, this side. So two pairs are parallel. Okay, and then these opposite sides also are equal. And then from these parallelogram, we can branch into a rectangle and a rhombus. Okay, right? Can you see that a rectangle is still a parallelogram because the two pairs of opposite sides are parallel? Parallelogram. The name parallelogram from parallel. Right, but this one, it has got special property because the angle is 90 degrees. It has an interior angle of 90 degrees. Okay, and then we have a rhombus, which is also a parallelogram, but it has a special property here. All the sides are equal, and the other properties we're going to what? To discuss. We're going to look at each shape. Remember, we're going to start with parallelogram, we go to the rectangle, we go to all of them, we're going to discuss them. And then after that, we go to the activity. Today, this will be the structure of the lesson. We're going to discuss everything. And then at the end, I'm going to give you an activity so that you apply what you have learned. Okay? That will be the structure of the lesson. Now, we have the square, which is a rectangle, which is a parallelogram. But why is it a square? Because the sides are equal and having 90-degree angles. Okay, right. Now we're going to discuss each quadrilateral. Now before we go there, we have kite and trapezium. Okay, kite and trapezium, one pair of opposite sides, and then trapezium, two pairs of adjacent sides equal. Adjacent means next to each other. This side is next to this side, this side is next to this side, so the adjacent sides are equal. This side is equal to this side is equal to this side. Okay, okay, right. Now we need to move on. Now we're going to start with a parallelogram. Now I want you to draw this diagram. Okay, so this is what you have to do. Be ready to draw the diagram. We're going to draw this diagram together, and then once I'm done this side, you should also be done on your side so that we can move together. I don't want anyone to be left behind and say, no, sir, I'm still drawing. Let's do it together. I'm going to guide you. Okay? Take your pen, your pencil, your ruler, if you have a ruler. Even if you don't have, try to use freehand, okay? So that we do it together. Now I'm going to draw. Let's draw the line 80. Okay, this is 80. Right, I've drawn that. And then I draw that. I draw that. I draw that. This is BC. Okay, so everyone must be having this. So this line is parallel to this line. And then this line is parallel to this line. Okay, let's do that. We're moving together here so that we don't have people being left behind. Let's draw the diagonals. Let's join BD. Okay, let's join AC. And then we name the point of intersection E. Okay, let's do that. We're moving together. Right, and then AE is equals to EC. Right, and then BE is equals to DE or ED. You have that? Okay. Right, let's name our angles now. Let's name our angles. Okay, we forgot something. AD is equals to the size, the length. This is equals to this, and then this is equals to this. Okay, put that. What else did you leave out? I think we're fine now. Now we have this angle being just one line. Okay, I just made a mistake here. We have this angle equal to this one. Just one line for the angle BAD there. And then we have this angle equals to this one. Okay? Let's move together, please. And then let's name our angles A1, A2. We have A1 here. We have A2 there. We have D1 there. We have D2 there. Hope you can see the D2 there. And then we have C1 here. We have C2 there. And then we have B1 there and B2 there. Is our diagram complete? Yes. Now everyone has the diagram. Everyone has the diagram. Now let's discuss our diagram now for the parallelogram. If ABCD is a parallelogram, the following properties hold. Right. Now it means AD is what? Parallel to BC. Just write this. Don't write a lot of things. Just write this. Okay. We're going to apply it later when you are doing the activities. AD is parallel to BC. Write it down. AB is parallel to DC. AD, this one, is parallel to this one. And then this one is parallel to this one. Okay. Right. Can you write that? AD is parallel to BC. AB is parallel to DC. Okay. Have you written that? Okay. Please send us your questions. 064-748-8913. Right. We go to the next one. AD is equals to BC. It means their lengths are equal. AD is equals to BC and AB is equals to DC. The opposite sides are equal. The opposite sides are parallel. For a parallelogram, the opposite sides are parallel. You can even write in words next to this. Opposite sides parallel. Okay? Even in short, just write op sides parallel. Okay? Here you can say op sides equal. Okay? Right. So that you don't forget. And then what else about a parallelogram? Right? AE. Do you see AE? Yeah, let me get red pen because it highlights better. Right? AE and EC, they are equal. And then they are being cut by the diagonal BD. Do you see that? And then BE and ED are also equal. And then they are being cut by that diagonal AC. So we say the diagonals of a parallelogram bisect each other. They cut each other into half. So that's why AE is equals to EC and BE is equals to ED. Please write that. The diagonals bisect each other. Just say diagonals bisect each other. Okay? Right, you can have that. You can write it down. Diagonals bisect each other. They cut each other into half. Then we move on to the other property. D1 is equals to B2. Why? Where is D1? This is D1 is equal to B2. Why? Alternate angles. Do you remember that? You see the Z? The Z here. Okay, you see that? Alternate angles. D1 is equal to B2, alternate angles. D2 is equal to B1, alternate angles. C1 is equal to A2, alternate angles still. Okay, you see VZ. You see VZ here. Okay, right. And then C2 is equal to A1. Okay, and then angle A is equal to angle C. Let me erase here, otherwise we won't manage to see anything. Let me try to erase here. Okay, right. Right, angle A, what happened to my pen? Angle A, my pen is not writing. Right, angle A is equal to angle C. You see that? So opposite angles of a parallelogram are equal. And then angle B is equal to angle D. The opposite angles of a parallelogram are equal. Okay? Right. So these are the properties of a parallelogram. Okay? These are the properties of a parallelogram. Can I give you 1 minute to just catch up? 1 minute, then we move on to the rectangle. Okay, also I want to see if there are any questions. Please send us your questions, 064 748 8913. Let's do that. 1 minute. Well done, grade 10s. Let me just talk about something I think may be confusing here. I think I used a wrong symbol here. It's not wrong, but someone may be confused and think this and this and this. Do you see that? You may think that they are equal, isn't it? Okay, they are not equal. So that's why here they use this one to show that this is equal to that. Let me just correct that so that we see that, because at the end you may think that AD is equal to BE. Why is that not? So let's use the symbol which was used by the original diagram there. Okay, thank you very much. Right, please send us your questions, send us your input. Please, we need to move together so that we benefit from the lesson. Okay, right, rectangle. If ABCD is a rectangle, the following properties hold. Right, now, one, we need to draw the rectangle. We need to draw the rectangle together. Okay, let's draw the rectangle together. Right, let's try to be fast. Rectangle, we know how to draw it. So it's AD there. This is a rectangle. You see that? Okay, and then A, D, B, C. Then let's draw our diagonals. BD, AC. Right, this side is parallel to this side. This side is equal to this side. Okay, and then this side also is parallel to this side. Okay, and then this side is equal to this side. Okay, right, now we have our E here, the point of intersection of the two diagonals, and then we're saying this side ABE is equal to what? Is equal to ED, and then AE is equal to EC. Do you see the difference now? It means the diagonals of what? Of a rectangle, the diagonals are equal. Okay, if you check the parallelogram, the symbols I used for this diagonal and the symbols I used for this diagonal were different because the diagonals are not equal. But for a rectangle, the diagonals are of the same length. Okay, right, did I leave out anything? Rectangles, right angles, yes, 90 degree. And then let's name our angles. 1, 2, 1, 2, 1, 2, 1, 2. I'm done with the diagram, so everyone must be done now. Okay, let's move on. Now, I'll try to move fast because we're almost 30 minutes into the lesson now. So, AD is parallel to BC and AB is parallel to DC. Just write that fast. AD parallel to BC, AB parallel to DC. I've explained this using the parallelogram, so I'm not going to repeat so that we move fast. Then the next one, AD is equals to BC and AB is equals to DC. So the explanation is the same as that one of the parallelogram. Okay? I will explain the part where it is what? Different. Okay? Right. AE is equals to EC is equal to BE is equal to ED. So now the diagonals are equal. And the diagonals, remember, they bisect each other just like with the parallelogram one. Okay? But because they are equal, therefore, AE is equal to EC is equal to BE is equal to ED. Okay? And you can say BD is equal to AC. The diagonals are equal. Okay? You can write short notes there. Okay? Right. And then D1 is, let me just explain one of them. Okay? Then you can write the rest. D1 is equal to what? Look at alternate angles. D1 is equal to B2. Do you see that? Alternate angles. We can also say C1 is equal to what? C1 is equal to A2. Alternate angles. Because these lines are parallel. Remember the Z or the N for alternate angles. Remember that. Okay? Write that fast. And then angle A is equal to angle C is equal to angle B is equal to angle D, and all of them are equal to 90 degrees. That's the right angle. That's why it's called a rectangle, because they have a right angle. Okay? Otherwise, the rest of the properties, they're just the same as those of what? Of the parallelogram. Okay? Should we move on to the next one? I want us to go to the activities. We're going to look at the application of all this. Right. And then, if ABCD is a rhombus, then the following properties hold. Right. Now, let's draw our diagram. I'm drawing the diagram with you so that I don't rush you. I know that you must use the same speed as mine. Right. Let's do it together. Let's draw the rhombus. This is the rhombus. Okay. Does it look like a rhombus? No. Try to make it better than mine. Try to make it better than mine. Great chance. Right. Okay. A rhombus, all the sides must be equal. All the sides must be equal. This looks like a parallelogram. Okay. But make it look like the original diagram there. And then, now this side is parallel to this side. This side is equal to this side. All the sides are equal. This side is parallel to this side, and then this side is equal to the other two sides. Or this one is equal to the other three sides. So all the sides are equal. You see that? Do the diagonals equal? No, they are not equal, but they bisect each other. So BD here, this diagonal, the longer one, and then AC, the other diagonal, the shorter one. They meet at E. And then there's something special. We haven't seen this since we started the quadrilateral. Where they meet the diagonals, what do you see? A 90-degree angle. So that's a special property of a rhombus. Please take note of that. The diagonals of a rhombus intersect each other at 90-degree angle. Please don't forget that. It's a special property. Once you get that, what type of a parallelogram is this? Once they bisect each other at 90 degrees, that's a rhombus. Okay? Right, now, did I miss anything? No. BE is equals to ED. And then AE is equals to EC. Okay? Right, and then what else? We can name our angles. 1, 2, 1, 2, 1, 2, 1, 2. Did I leave anything out? Please correct me. Send the WhatsApp 064-748-8913. I think I'm done with everything. Now let's go to our notes. Same thing. AD is parallel to BC. AB is parallel to DC. Write that down. AD is parallel to BC. AB is parallel to DC. Okay? And then AD is equal to BC, is equal to AB, is equal to DC. All the sides are equal in length. For a rhombus, all the sides are equal in length. And then AE is equal to EC, then BE is equal to ED. The diagonals bisect each other, they cut each other into half. D1 is equal to D2, another special property. D1 is equal to D2. Let me show you that. This angle is equal to this angle. 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 So what do the diagonals do when it comes to the rhombus? The diagonals of a rhombus, they bisect the interior angles. It means they cut the interior angles into half. If this angle is 100 degrees, it means you're going to have 50 this side and 50 this side. Another special property for rhombus. Okay, we never said such when we looked at what? At the other quadrilaterals. Right. Now, the other one, A1 is equal to A2. We've talked about that. C1 is equal to C2. Okay. Right. A1 is equal to, because these opposite angles are equal. If this whole angle is 100 degrees, this one also will be 100 degrees. Remember the parallelogram one, the opposite angles are equal. Okay? Right, just write those notes as notes. Some of things you may see them later on your own. Okay? We're trying to cover as much as possible. Okay? E1 is 90 degrees. What did I say about this? AC is perpendicular to BD. It means that the diagonals bisect each other at 90 degrees. Grade 10s, if you prove that your diagonals bisect each other at 90 degrees, your quadrilateral is a rhombus. Okay? Remember that. Now, a square. Right. We're going to, let me just go through the square one so that we can try to do the activities. Right, we're saying that AD is parallel to BC. Some of things, if you check, they are the same from the parallelogram. Okay, AD is equal to BC, AB, not equal, sorry, grade 10, sorry, means parallel. AD is parallel to BC, AB is parallel to DC. I hope I wasn't using the wrong term there. This means parallel. Please don't get confused. Parallel, equal is equal sign. Right, now, and then AD is equals to BC, is equals to AB, is equal to DC. All the sides of what? All the four sides of a square are equal. And then AE is equal to EC, is equal to BE, is equal to ED. Just like the rectangle, the diagonals are equal and they bisect each other. So this is equals to this. This is equals to that. Okay? Right. And then D1 is equal to D2, just like the rhombus. Okay? The diagonals bisect what? The 90 degree, because the angle there for a square is 90 degrees. So it means it's going to be 45. Okay? Right. And then A is equal to C is equal to B. Angle A is equal to angle C is equal to angle B is equal to angle D. And all of them are equal to 90 degrees. Right. And E1, just like the rhombus, right, will be equal to 90 degrees. Okay? AC is perpendicular to BD. So now, what will be the difference between a rhombus and what? And a square. Now, the square will have diagonals bisecting each other at 90 degrees, but also their interior angles are all 90 degrees. You see that? That's how we differentiate between a square and a rhombus. You must know, a rhombus is a parallelogram. Okay? But now, what makes it special? The diagonals will bisect each other at 90 degrees, and then the interior angles are not 90 degrees. You see that? You see? And then a square, yes, it's a parallelogram, it's a rectangle, But what makes it special? The diagonals bisect each other 90 degrees and the interior angles are 90 degrees each. Okay? Alright. Have we done all of them? I think we are left with trapezium. Now the parallel, just one pair of parallel sides, this side and this side. So this angle here is equal to this angle here, the Z, the alternate angles. Do you see that? And then this angle here is equal to this angle here. Okay? And then this side AD is parallel to BC. Okay? That's a trapezium. That's a trapezium. Okay? Right. And then a kite, the following properties hold. Right, a kite AB, adjacent sides are equal in length. So this side is equal to this side is equal to this side. Adjacent sides are equal in length. Then BC is equal to DC. You see that? AB is equal to AD. Okay? And then BE is equal to DE. See that? This diagonal, the longer diagonal, bisects the shorter diagonal. Okay, it cuts the shorter diagonal into two equal parts. So BE is equals to ED. I think I'm moving fast now. I'm trying to cover things, but please do send us your WhatsApp 064 748 8913. I want us to do an activity so that we can see how we apply these things. Okay, right? Are you fine with the kite? Okay, and then A1 is equals to A2. Remember, these are special properties that you must know from now till you write your metric. Okay, and then also C1, this angle will be equal to this angle. Okay, right, and then B is equals to angle B is equal to angle D. Okay, this angle is equal to this angle here. Right, and then angle E2 is 90 degrees. So they bisect each other at 90 degrees. Okay, right. And then AC is perpendicular to BD. That's it. That's the kite. That's the kite. Okay. And then I want to give you 1 minute. 1 minute. Just take notes. Okay. Just draw the kite first, and then you try to take these notes, and then we're going to look at them later. Just 1 minute. Let's try that. Right, welcome back, grade 10s. Did you manage to copy the notes? I really hope so. Please continue copying if you haven't finished. Continue copying. But I don't know if you are going to manage to multitask. I want to talk about something which is very, very important. I think I missed that one. Right, we talked about the parallelograms, the rhombus, the rectangles, and all those things. Right, if you check, the parallelogram is like this. Okay, this is a parallelogram. This side is parallel to this side. Okay, and then this side is parallel to this side. This side is parallel to this side. What can you say about this angle and this angle? Angle A and angle B. What can you say about them? Remember, we've talked about alternate angles, angles opposite, on the opposite sides of what? Of a parallelogram and all that. But we didn't talk about this one. So now, what can you say about angle A and angle B? What type of angles are those? Remember, AC is parallel to BD. They are co-interior. Okay, they are co-interior. And then co-interior angles are supplementary. They add up to 180 degrees. If you add angle A plus angle B, we'll get what? 180 degrees. And you put your reason, co-interior angles equal, and then AC parallel to BD. Don't forget that. Okay, even this one and this one, A and C, they add up to 180 because this is parallel to this. Okay, those are co-interior angles. It's a very, very special property. We can use it to solve problems with quadrilaterals. Okay, right, let's move on to the activity now. ABCD is a polygon. Are we told that it's a parallelogram? No, it's a polygon with 4 sides. Calculate the value of x. What do we do, grade 10s? Hence show that ABCD is a trapezium. Now, how can we show that ABCD is a trapezium? Okay, if we add, maybe say this angle and get 180 degrees, it will mean that the AB is parallel to DC. If we add this one and get 180 degrees, it means AB is parallel to DC. Even if we add this one and get that it give us 180 degrees, then means AD is parallel to BC. Do you see that? Now, but the first thing we have to do is to find the value of x, and then after finding the value of x, we find the size of the angles. Okay? Right, I would like to invite you to try to be ahead of me. Unfortunately, I'm not going to give you time to try things today, okay? Because I've got a lot of questions that I want us to do. So try to be ahead of me, okay? Is it fine? Try to be ahead of me, please, if you can, okay? I'll try to be slow and try to explain. I usually like you to try things, but because of time, I will guide you, okay? When I'm guiding you, does not mean that you must wait for me and copy everything. No. Try to be ahead. Then you keep on correcting yourself, okay? Let's try that strategy. Now, let's move on. So what do we do, grade 10s? Should we add our angles? Angle A plus angle B plus angle C plus angle D. Right, if we add them, what do they give us? They give us 360 degrees, isn't it? Let's do that. Do that now. 8x plus 2 in brackets plus 4x plus 2 in brackets plus 5x minus 2 in brackets plus x minus 2 in brackets equals 360 degrees. And then what's the reason? Sum of angles of what? Of a quadrilateral. Okay, right, now like this. Did you get it like that? Okay, what will be the next step now, grade 10s? Try to move fast. You must do things before I show you. What will be the next step? We have to simplify this algebraic skeleton this side. We need to simplify things. Remember simplifying? What we do, we collect like terms, we deal with like terms, okay? So it's going to be 8x. There's no negative there for the ones with x. Let's just add them. 8x plus 4x, what is it? 12x. 12x plus 5x, 17x. 17x plus 1x is 18x, isn't it? So the ones with x will give us 18x. Let's go to the constants. 2 plus 2, I'm adding this now. 2 plus 2 is going to be 4. 4 minus 2 is going to be 2. 2 minus 2 is going to be 0. So it means we're just remaining with 18x. Do you agree? So 18x is going to be equal to 360 degrees. Then what do we do after this? Remember, I said you must be ahead of me. We'll say divide by 18 both sides, isn't it? Divide by 18 both sides. X is equal to 20 degrees. Step number 1. Now, what will be the size of each angle now? Okay, where there's x here, put 20. 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 And I'm going to give you 1 minute to do that. Get the angle A, B, C, and D in 1 minute. You can even use your calculator, just calculator, and then write your size, angle size now. Then calculator, angle size, your calculator, angle size, your calculator, angle size. Then we're going to mark the final things. Let's try that for 1 minute. Welcome back, grade 10s. What did you get for A? A, we got 162 degrees. Let's write 162 degrees here. And then what did you get for B? 82 degrees. 82 degrees here. And then what do you get for C? We got 98 degrees. 98 degrees here. Then what do you get for D? We got 18 degrees. 18 degrees there. Okay, right. See that? Now, is this a trapezium? If we add this angle here and this angle here, we must get what? We must get 180. Ne? Okay, now we said 162 here, 18 here, then 82 here, 98 there. Was it like that? Yes. Now, if you say 162 plus 18, you will get 180 degrees. Means co-interior angles, they add up to what? To 180 degrees. Therefore, AB is parallel to DC. So we've proved that this is a trapezium. But if you add this and this, you won't get 180 degrees, showing that AD is not parallel to BC. Okay? If you add this one and this one, you'll get 180 degrees, showing that what? Showing that AB is parallel to DC. So we can say AB is parallel to CD because co-interior angles are supplementary. You see how I write the reason now? Okay? Okay. So if the sides are parallel, then co-interior angles are equal. And if the co-interior angles are equal, we say co-interior angles are supplementary. Okay? Which is the converse of that part. Right. And then we've done that the first part there. Okay? And then example 2. I'm going to explain. It means, again, let's use the same strategy where you try to be ahead of me. Okay? Right. We can do things differently. I'll do the one that is going to be shorter for me. Okay? Right. Calculate DELM is a parallelogram. Please read the information. It's very, very important. Calculate the value of x and hence the sizes of the interior angles. What can you do with this? I can say this angle is equal to x because opposite angles of a parallelogram are equal. I can say this angle is also equal to 2x because opposite angles of a parallelogram are equal. And then I can say 2x plus x plus 2x plus x is equal to 360 degrees because interior angles of a quadrilateral add up to 360 degrees. Then I solve for x. It's still okay. But I'm going to use a shorter one. What do you think I'm going to use? This angle and this angle. They must add up to what? They must add up to 180 degrees. Why? Because they are co-interior angles. This side, DM, is parallel to EL. So I can add these angles and say they are going to give us 180 degrees because they are co-interior. Okay, that's what I'm going to use. Now, here we say 2x plus x equals to 180 degrees because these are co-interior angles. Okay, right, and then 3x is equal to 180 degrees. Then divide by 3 both sides, x is equal to 60 degrees. Someone could have used these angles, x and 2x. What is going to be 6x? Remember, is equal to 360 degrees. I'm not going to write the reason. I just want to show you that you're going to get the same answer. Divide by 6 on both sides, x is equal to 60 degrees. You see that? We're going to get the same answer. Right. Now, x is 60 degrees. Now, what was the question? Hence, it means use the answer you got to solve this one. Hence. So, let's use what we got to solve this, to find the sizes of the angles. So 2 times x, x is 60. 2 times 60, 120 degrees. This one is 60 degrees. This one is 60 degrees. This one is 120 degrees. Do you see that opposite angles are equal? Okay, and then 120 plus 60 is 180. Do you see that? Okay. Sometimes you must check if your answers make sense at the end. You see, if it's a parallelogram, then co-interior angles must be supplementary. Okay? Right. Now, we got all that done. Right, activity 1. Activity 1. I can see this diagram here. Okay, let me see if it's going to be. Let's see. Okay. Let me write it for you. I'm going to write using my pen. Okay, sorry for that. You see the font size just moved. Let me move. Okay, let me write it with a pen. Now, this is, let's just forget about this one. Forget about this one. Okay, this is 2x minus 30 degrees. And then this is 2x plus 10 degrees. Right, now, so this is this angle here and this angle here. Okay, so it says find the sizes of the interior angles of the parallelogram. We're left with 5 minutes, but within these 5 minutes, let's just try to do this activity. Then the other one I'm going to give you as homework. Okay, right, now just try to find the value of x, just that, in 1 minute. Can you try, please? Right, this is a parallelogram. Given that we're given, you can put this, it's a parallelogram. Just try that. Just find the value of x. Use the faster method that I showed you, the co-interiors one. But if you want all the angles of the quadrilateral, it's fine. 1 minute. Right, welcome back. Did you find your x cretans? I really hope so. Right, we say this one is 2x minus 30 degrees. This one is 2x plus 10 degrees. Okay, now these are co-interior angles because this side AB is parallel to DC. So if we add them, they must give us what? They must give us 180 degrees. So let me write here. So it's 2x minus 30 degrees, okay, plus what? Plus 2x plus 10 degrees, okay, is equals to 180 degrees. Why am I saying that? Because co-interior angles are equal. Then AB is parallel to CD. Okay, you see that? Now let's simplify our thing. 2x plus 2x is going to be what? It's going to be, please be careful, don't do that, especially if there's a negative here. Okay, let me remove brackets first because I don't want you to make that mistake. Let's remove brackets first. And then it's going to be 2x minus 30 degrees. If it's minus here, it can change things. So it's going to be, because it's plus here, so it's going to be plus 2x plus 10 degrees, okay, is equal to 180 degrees. Now we can collect our like terms. So 2x plus 2x is 4x. Then minus 30 degrees plus 10 degrees is minus 20 degrees. And then it's equal to 180 degrees. And then what you get, you can transpose, becomes plus 20. So it means 4x. Where did I get the squared? You see, learners, I'm used to this square thing. Degrees. Not just x, just x. Okay, right. And then equals to 200 degrees. Okay, and then we divide by 4 on both sides. X is equals to 50 degrees. You see that? Now x is equal to 50 degrees. So now we can find our angles here. We put your 50 here. You put your 50 there. What is 2 times 50? Is 100. What is 100 minus 30? Is 70 degrees. So this one is 70 degrees. So this one also is going to be 70 degrees. And then what is 2 times 50 is 100. What is 100 plus 10 is going to be 110 degrees. Do you see that? If you say 110 plus 70, you get 180 degrees. Okay, right? So that is the value of x and the sizes of the angles. Right? Let's take a short break, and then after that break, we just come and summarize the lesson. Just let's take a short break. Welcome back, grade 10s. I want us to summarize our lesson. Okay, right. I really hope that you learned something. Please continue to try your best. Look for past examination questions and you work on these geometry questions. Okay, right. I really hope that you gain something and you may use it even to learn more, okay, about these quadrilaterals. Okay, right. Let's summarize our lesson. What did we learn today, grade 10s? We said that the interior angles of a quadrilateral add up to 360 degrees. Okay, right. The opposite sides of a parallelogram are equal in length. The opposite angles of a parallelogram are equal. The opposite angles are equal. Okay, and then the diagonals of a parallelogram bisect each other. It means that they cut each other into what? Into halves. And then the diagonals of a rhombus bisect each other at right angles. These are very, very important points. Okay, grade 10s. Remember them. Right? And then we say diagonals of a rhombus bisect the interior angles. If the interior angle, I gave you an example, if it's 100, it's going to be divided into 50, 50. Do you remember that? Okay? And then all sides of a rhombus are equal in length. Okay? And then opposite sides are parallel. Opposite sides of what? Of a rhombus are parallel. Opposite angles are equal. That is for the rhombus. And then the diagonals of a kite intersect at 90 degrees, just like the rhombus one and the square one. Okay? But they are not equal. Do you remember that? The kite is, the diagonals are not equal. There's a longer one and a shorter one. Right? And then the longer diagonal of a kite bisects the other shorter diagonal at 90 degrees. Do you remember that? And then two pairs of adjacent sides for a kite are equal. Adjacent means the ones next to each other. Like this one and this one, this one and this one. Okay? Right? A single pair of opposite angles are equal. That is for the kite. Okay? And then the longer diagonal bisect the corner angles. This angle is equal to this angle is equal to that angle. Right. And then we still have more. Now, thank you very much, grade 10s. We've come to the end of our lesson. Okay. Right. Let's meet in our next lesson. Goodbye.